the single most important key message that has come out of this new fifth assessment report is that we are more confident than ever that the changes in climate we have seen in the 20th century and into the 21st century are essentially caused by man, and we are more confident than ever that these will pose severe threats as we go into the future towards the end of this century. So to be more specific, we find that there is no way to explain the rising global temperatures that we've seen in the 20th century, the increased number of heat waves in locations around the world, the increasing trend towards heavier amounts of rainfall, more intense rainfall events. We find no way to explain this other than the fact that humanity is steadily increasing the amount of carbon dioxide in the air, and the effect of carbon dioxide is to warm the planet through the greenhouse effect. So one of the key messages from IPCC is that we now think it's extremely likely that a large amount of the climate change that we've already seen is caused by man. And then looking to the future, we're more confident than ever that these changes will continue for the next, certainly the next 100 years, really for the foreseeable future, into many hundreds of years, in fact. So what sort of effects will we see in the future? We will see effects ranging across a wide variety of meteorological and climatological variables. We've seen the Arctic sea ice decrease each year. We believe that in summertime that will probably have vanished altogether by the mid-century. We've seen the number of heat waves around the world increase. That'll continue. We've seen sea level rise. This will continue. We've seen intense rainfall events and flooding events become much more commonplace, and this will continue. So really climate change, although the headline figure is in terms of global mean temperature, the actual manifestation of it will be in many different types of meteorological and climatological variables that will affect us all individually. Yes, I think the question of trust, how people can trust the science, is an important one. I think the most important point to get over is that scientists are themselves not environmental activists. They're not trying to kind of promote a particular set of policies or a particular, set of solutions to climate change. A scientist, in a way, and I consider myself to be somebody like this, is trying to view the problem rather dispassionately and sort of neutrally, and just try to say what are going to be the consequences on our physical climate system if we double, for example, the amount of carbon dioxide in the air over and above its pre-industrial revolution values. So we're not trying to promote a particular way of living. We're not trying to be spokespersons for government policy. We're just trying to say, how can we best apply the scientific tools we have at our disposal to answer this question? So we use these very complex climate models. These are essentially the laws of physics applied to science, but they need to be run on big computers to get numbers. And we try to incorporate as best we can all of our scientific knowledge and capability into these models. So I think the important point to make here is that scientists are coming at this problem in a very neutral way. So there are uncertainties, and there are certainly aspects of the science that could certainly benefit from further research and indeed improved modelling and improved observations and all this sort of thing. But this is our best effort to try to understand this important problem from a completely policy neutral perspective. It's first necessary to reflect on the fact that the climate system is an incredibly complex and kind of interacting system. It involves not only the atmosphere and all the weather systems and kind of turbulence and things that happen in the atmosphere, it's the oceans, it's all the ice sheets and sea ice and mounting glaciers, it's the general land surface, it's the biology on the surface of the land and in the oceans. All these things have to be represented, and I think it's probably true to say there is no more complex problem in computational science than trying to simulate and predict climate. And so we need very powerful computers to actually get the numbers that can then inform on policy or inform on how we as a society should be, what sort of infrastructure we should be investing in to adapt to future climate change if we can't reduce our emissions sufficiently, which is likely. We need these big computers to provide detail, and I think this is one of the big challenges for the future. We're in a slightly unusual situation in science where we mostly know the equations that we need to solve. It's just we don't actually have quite powerful enough tools yet to solve these equations as accurately as we would like. So for me, certainly, investment in supercomputing technology lies really at the heart of making progress in providing sharper and more accurate predictions of future climate. I think one can look to other areas of science where collaborating on scientific infrastructure has led to a real kind of step change in our understanding of the universe. I mean, a classic example is CERN, the High Energy Particle Physics Center in Geneva. This is funded by many nations of the world, and it does things that no individual country could afford. It's by pooling resources that it has found, the Higgs boson, for example. That never would have been possible had that type of physics only been funded at the national institutional level. Astronomy is another good example of where infrastructure has allowed the sort of telescopes to be built that individual countries would not have been able to afford. And we're now developing, a nuclear fusion center, which is a joint research center between Europe, the United States and China to develop nuclear fusion, which of course is a essentially carbon-free energy source. So my view is that we could do more, I think, in this area in climate prediction. I mean, it is such an important problem, not only in terms of trying to understand how global climate will change, but how it will change at a regional level, how it will change for the UK or for China or for Bangladesh. I mean, these are very important problems for countries that are trying to plan infrastructure to adapt to climate change. And I think if we were to pool our resources, we actually could make more rapid progress than we're currently able. Now, it's easy to say this, at an abstract level. It's of course a great involves great political challenges and so on, and it needs the community to come together. I don't want to necessarily make a great prediction about whether this will come about or not. I think the only thing I would say is that by people like myself and my colleagues promoting computing actually has raised this issue to the fore, and just recently, very recently, the Met Office has been funded an extra £100 million by the government and George Osborne in particular, because of the recognition at government level of the importance of this issue of supercomputing for climate change. So even by talking about these international projects, we have actually had an impact on at least raising the profile of this important topic.